Good afternoon, guys. Today we will be taking taxonomy. It can also be called classification of living things. Like classification of living things. But before we continue, I would like us to know the need for this topic. We have a lot of living things on earth. We have a lot of living organisms. So it was difficult for scientists to know which is which, where to place this and where to place that. Even in Yoruba land, our normal rat. Some people call it ekute, some people call it okete, and many other names. So this is why scientists have come together because of the barrier we have with language, with different languages. So scientists have come together to do what? To classify living things, to give them specific names, to find more. And now that's what about what this topic taxonomy. Like biology, we always derive what. This word taxonomy was derived from the Greek word taxis and what nomy. Taxis means what? Arrangement. And nomy means what? Method. So we can just say taxonomy should be what? The method of what? Arranging. So that's just a simple way. But let's give a proper definition of taxonomy. Taxonomy can be defined as the way of finding, describing, classifying, and what? And naming organisms. So before this, the first scientists to make effort to classify living things was who? Aristotle. We all know who Aristotle is. Aristotle came to science also. He wanted to do something new. So he tried classifying living things, but it wasn't recognized. So in the year 1753, a Swedish botanist, Carolus Linnaeus, was the one who finally made a breakthrough. He classified living organisms into what? Plants and animals. He did that of plants in 1753. He did that of animals in 1758. In 1758, he published a book called what? System Naturally. So before Carolus Linnaeus, John Hay, a British naturalist, is also a botanist. He also tried to classify what? Living organisms. But what? Carolus Linnaeus was the only person which his classification was made a breakthrough, was he classified living organisms into what? Plants and animals, as I have said before. He did that of plants in 1753, and he did that of animals in 1758. That was 5 years ago. So now let's move on. So after that, after he has classified plants and animals, so we now have what? We still have a lot of what? Plants and animals. So scientists now look for a way to give all these plants and animals, all these organisms, to give them a name everyone could recognize, irrespective of the culture or wherever you are from. So a scientist from Nigeria, from China, from America, from US can identify rat as what? Ratus. Rat in Yoruba is eku. In China it could mean another thing. So if this continues, it will be difficult for scientists to know the organisms they are talking about. So because of that, we come with the process of what? Nomenclature. Nomenclature means what? Naming organisms. There are processes in nomenclature to write the botanical, what we know about botanical name. To write the botanical name of organism, we have to go through some processes. Because if you write the botanical name the way we write the normal name of organism, you might just fail hopefully in the exam. So now let's look at this. One of the ways to write what? Botanical names. Rat. The botanical name for rat is what? Ratus. Note. When writing the botanical name, the first name is what? Is the generic name. Also called what? The general name. Why this word is the word? Specific name. Let's continue. The generic name is the general name for that organism. Why the specific name is the name of that species. Now let's look at it. Let's take a look at yam. Yam is what? Dioscorea species. But we have different types of yam. We have yam, we have water yam, we have normal yam, we have cocoa yam. So the generic name for yam is Dioscorea. Why the specific name will be what? Will be different, because they are all yams, but they are what? They are what? Different species. Take a look at it. The generic name, this is the generic name for rats, and this is the what? The what? Specific name. Same as what? Other organisms. Now let's look at the way. You will see that this first one, which is the generic name, starts with a what? A capital letter. And the other one, which is the specific name, starts with a what? A small letter, like the lowercase, this is uppercase, and this is the lowercase. Please be careful when writing the botanical name for any organism. The generic name starts with what? Capital letter, while the specific name starts with what? Small letter. And there must be space, as you can see, and it must be underlined. You notice that in your textbooks they are not underlined because they are written what? In italics. They are not written the normal way. That is why they are not underlined. So if you are also typing, maybe the exam is about typing, you don't have to underline when they are written what? In italics. You don't have to underline them. But in your WAEC examinations, you have to what? Underline, because you are not typing. The generic name, don't forget the name, begins with a what? A capital letter. Why the specific name is a what? A small letter. Please don't forget it. Very important. Let's look at the botanical name for other organisms. So with rats having a botanical name of Ratus ratus, so any scientist from China, from Nigeria, from Australia, when you just come, okay, we want to talk about Ratus ratus, all of them will understand that, oh, today we are talking about the what? Organism rat, which is what? Ratus ratus. Next organism that we have to look at is botanical. We'll be looking at the botanical name for few organisms. Let's look at lion. Lion is Panthera leo. Panthera leo. Please don't forget, this should be in the what? In the lower case with small letter, and the P should be in capital letter. Please don't write Panthera leo like this. This is gone. This is the correct way to write what? Botanical name of what? Organisms. The P must be in the capital letter. Now let's move on. Another organism, we have what? Banana. Banana is what? Musa species. Musa, the normal Musa. Musa species. These are not important because you are right. You are taking a what? A written examination, an exam which you have to write. So be very careful. Musa, the N should be the capital letter because it is the what? It is the generic name. Don't forget. Why the species is the what? Specific name. Another organism is rice. We all know rice should be what? Oryza sativa. The O should be in capital letter. Oryza. And the S should be small letter, sativa. Please don't forget. And you underline them separately. Oryza sativa is never written like this. No, this is the wrong way to write the botanical name of organisms. Other organisms, we have pawpaw, which is what? Carica papaya. We have yam, which is what? Dioscorea species. We have maize, which is what? Sea maize. All organisms on earth have their what? There was specific name, their generic name, then just say they have their botanical name. Human being, our botanical name is what? Homo sapien. We are what? Homo sapien. So now let's continue. We are done with nomenclature. We move to hierarchy of classification. Look at the hierarchy of classification for man. The kingdom for man is what? Kingdom Animalia. Because what? We are animal. Our phylum is what? Mammalia. Because we are what? We are mammals. Why are we mammals? Because we show a lot of what? Parental care, and our hierarchy period of mammal. The class for human being is what? The class Chordata. Our order is what? Primate. Then we move to our family. We belong to the family Hominidae. And we have the species Homo. The genus Homo, and the species was Sapien. So now this is the order of classification. You see from the hierarchy of classification, we got our botanical name, which is what? Homo sapien. Our kingdom is Animalia, for we are animals. Our phylum Mammalia. Our class is what? Chordata. Our order is primate. Our family is Hominidae. Our genus is Homo, and our species is what? Sapien. So this is the hierarchy of classification for what? For man. You can get hierarchy of classification for other living organisms. So now let's move on. This kingdom is now furtherly divided into 5. We have 5 kingdoms. I was talking about the scientists the other time, which is what? R.H. Whittaker. R.H. Whittaker was born. R.H. Whittaker. R.H. Whittaker was the scientist that divided kingdoms into 5. Divided kingdoms into 5. Which are what? Kingdom Monera, Kingdom Protista, Kingdom Fungi, Kingdom Plantae, and last we have a Kingdom Animalia. Still on the journey to classify living organisms, but the topic we are doing today is what? Taxonomy, which is known as what? Classification of what? Living things. R.H. Whittaker helps us a lot because he classified the kingdom into 5. Now if we start from this 5, Kingdom Monera. Kingdom Monera, we have what? The simplest organisms in what? Kingdom Monera. Please note that viruses are not under any of this kingdom. Because why? Because viruses exist as what? Living and non-living things. Like when they are living things, they are alive, and when they are non-living substances, they are what? They pretend to be non-living things. They act what? Crystalline. Let's take example of our coronavirus. Why do you think when coronavirus is on the surface, it stays there, it doesn't die? Because it's a virus. That is one important thing about viruses. When they are living on non-living things for years, they pretend to be non-living. Immediately they gain entrance into the body of a living organism, they start their work. They start to manifest. That is one thing about viruses. That is why they are not classified under any of these kingdoms, because they act to be non-living and non-living things. And why is it that? Because their cell is made up of what? DNA or RNA, but never both. Let's continue with this. Kingdom Monera, we have the bacteria in this kingdom. We have Kingdom Monera is divided into 2, which is what? Schizophyta and Cyanophyta. Schizophyta and what? Cyanophyta. But before we go deeper into that, I would like to tell you characteristics of organisms in Kingdom Monera. First of all, organisms in Kingdom Monera are what? They are prokaryotic. What do I mean by prokaryotic? They do not have nucleus. They do not have, they do not have essential cell organelles. They do not have nucleus, they do not have chlorophyll, they do not have essential cell organelles. That's why they are the simplest organisms. Sometimes they are non-motor. That means they do not move. That is it. Their mode of nutrition is heterotrophic, because they live on food that are produced for them. Examples of organisms here we have bacteria. Take a look at our bacteria. It's a very simple organism. They are microscopic. They cannot be seen with our naked eye. So, and cyanophyta is our what? Blue-green algae. Where we have what? Cyanophyta. That's all about Kingdom Monera. And let's proceed to Kingdom Protista. Kingdom Protista has a little advanced organisms than what? Than the ones in Kingdom Monera. This is just what the kingdom is all about. As we move down, we get to see more complex organisms, more organisms that have more characteristics. Now let's move to Kingdom Protista. Kingdom Protista is now divided into 2. It's divided into protozoan and protophyte. Please, in biology, when you hear the word one, it means animal. And when you hear the word fight, it means what? Plant. Take note of this, it might help you a lot. When you hear the word swan, biology, it means animals. When you hear the word fight, it means what? Plants. So now, protista is now divided into two. Divided into what? Protozoan and what? Protophyte. Protozoan and what? Protista that acts like what? Plants. That's protophyte. And protozoan are the what? Protista that acts what? That act like what? Animals. Now the protozoan, dwell mainly on the protozoan. The protozoan is now divided into four classes. We have the class Sarcodina, the class Mastigophora, the class Ciliata, and the class Porozoan. These four once again, we have the four classes. I told you we have the Sarcodina, we have the Mastigophora, we have the what? Ciliata, and we have the what? Porozoan. The class Sarcodina is where we have the amoeba. We all know it as amoeba, but it's amoeba proteus. And we have what? The Difflugia species. And the next class is what? The class Mastigophora. Under the class Mastigophora, we have what? Euglena viridis and Trypanosomas gambiae and Trypanosomas brucei, which is what? Causative organism for what? Trypanosomiasis, which is what? A simply sickness. The vector for this causative organism is what? Rosolina species, which we all know as what? Testes fly. And the next one we have the class Ciliata. Ciliata is the organism, the slipper-like organism. It is under the class Ciliata because it moves with what? With the cilia. This is where we have what? Paramecium. Paramecium is a slippers organism. And last we move towards Porozoan. This class is called Porozoan because it produces spore during its reproduction. And under this we have the example Plasmodium falciparum, Plasmodium malariae, and Plasmodium ovale, which are the causative organism for all forms of what? Malaria. Please, in the exam, there will be a trap for you. You will be asked, which of the following organisms cause malaria? You will see mosquito, female, you see mosquito. Let's start with that. You will see female Anopheles mosquito. You will see Plasmodium falciparum. Please don't fall into the trap of picking mosquito, picking female Anopheles mosquito. Plasmodium falciparum is a causative organism for malaria. Female Anopheles mosquito is just a carrier. So if you are asked which of the following organisms is a carrier for malaria, that's when you get to choose female Anopheles mosquito. But when you are asked which of the following organism causes malaria, please choose Plasmodium falciparum. We have different kinds of malaria. We have the cerebral malaria and other types of malaria. That's why we have different species of what? Plasmodium. As I was saying the other time when I was talking about the botanical name. But look at Plasmodium now. We have Plasmodium falciparum, Plasmodium ovale, and Plasmodium vivax. We all know they are all Plasmodium, but they are of different species. That is what I want us to get when it comes to botanical name. It might be the same organism, but of different species. Look at our plantain. We have the plantain we can eat, and we have the one we fry. They are all plantain, but they are of what? They are of different species. That is just about when it comes to finding living organisms. So I think we are done with. We all know amoeba. Amoeba does not have any shape. Here people insult you, she looks like an amoeba. Because why amoeba does not have shape? Why does amoeba not have a shape? Because it does not have pellicle. It does not have pellicle. This makes it ball, shapeless organism. It moves with the aid of what? Pseudopodia. When you hear the word pseudo means false. What is not true? So it moves with a false movement. The aid of what? Pseudopodia. Its mode of nutrition, amoeba's mode of nutrition is what? Holozoic. It eats by engulfing any substances it sees. It is found in dishes and ponds. Now let's move to what? Euglena. Euglena can act as a plant and can act as a what? Animal. The presence of chloroplast makes what? Euglena a plant. While the presence of eye spots, gullets, pellicle makes it what? Makes it an animal. Euglena has a paramillion granules, which is what? Where it stores its food. And Euglena also have what? pyramid, which is what produces the paramillion granule. Now let's move to the next, which is what cilia, paramecium. Paramecium is a slippers-like organism. It has the shape of slipper. I will try drawing all the organisms, but paramecium has the shape of slippers. And paramecium has two contractile vacuoles. Paramecium also has two nucleus. Paramecium also has this organelle called trichonis. The trichonis is what the paramecium uses as defense. It uses the trichonis to defend itself. And next we move to sporozoa. The sporozoa does not have any organelle for movement. It doesn't move with any organelle. So, and the sporozoa, I told you the other time that sporozoa is where we have what? The Plasmodium falciparum, the Plasmodium, the causative organism for malaria. They do not move. When they get to the body of man, they have their erythrocytic stage. This erythrocytic stage is the stage where they multiply. Note that the release of hemozoin into the body by Plasmodium falciparum or any other species of Plasmodium is what causes the fever, the chills you have when we have malaria. When you start feeling feverish, which are the symptoms of malaria, is because Plasmodium species has released hemozoin into our body. Before we continue with the kingdom fungi, I would like to give drawing of amoeba. As you know, amoeba is an organism that does not have shape. It has no shape. It has no shape. This is just what an amoeba could look like. So now let's go to the drawing of amoeba. Amoeba at the center has a what? Contractile vacuole. Contractile vacuole. Which is what for what? Osmoregulation. What is osmoregulation? Osmoregulation is what? Salt and water balance. That is what the contractile vacuole is used for. And somewhere here, amoeba has the what? Food vacuole. So when you have food vacuole, you know exactly what that is used for. And here we have what is cytoplasm. Cytoplasm, the liquid portion of everything here is what? Cytoplasm. And here we have the what? Endoplasm. Somewhere outside here we have the what? Ectoplasm. Endoplasm. Somewhere outside here we have the what? Ectoplasm. And here is where we have what? Pseudopodia. Pseudopodia is organ of what? Of movement. Everything here is what? Cytoplasm. And don't forget that the nucleus is what? Nucleus of the what? Amoeba. Nucleus of the what? Amoeba. So now this is just what the organism amoeba looks like. What the organism amoeba looks like. So at the center we have the nucleus which is responsible for life activities. Here we have the food vacuole, we have the contractile vacuole. You know that any cell without the nucleus is just not performing life activities. We have the pseudopodia, we have the cytoplasm, we have the ectoplasm, we have the what? Endoplasm. And this is all about the amoeba. So now let's move to the drawing of the organism. You can check more of the textbook to get a well-defined diagram of the amoeba. But this is what I can do. We have to draw our paramecium. Paramecium. Sorry, but it has the shape of slippers. Why do you think amoeba is shapeless? Amoeba is shapeless because it does not have pellicle. Please note that it does not have pellicle. But other organisms like Paramecium, Beginner, they have shape because they have what? Pellicle. They have specific shape because of their what? Pellicle. So now let's continue. This is cilia. Here we have the what? Anagrove. Don't forget I told you here is bullet. Don't forget I told you that it has two contractile vacuum. Two contractile vacuum. And I ask you what is the difference between amoeba and paramecium. The presence of what? Two contractile vacuum and two nucleus. This is the first contractile vacuum. And the second one is somewhere here. Second contractile vacuum. And don't forget also have what? Two nucleus. So this is the what? Meganucleus. This is the what? Micronucleus. And here we have the products. Yes, we have the products there. And somewhere here we have, don't forget to see, and somewhere here we have what? Trichomes. Which is the what? Organ of what? Defense. Organ of what? Defense in the what? In the what? Paramecium. Let's see what? Paramecium. So that's all for today. But we are not done with the topic classification of the. This is a very important continue now.